Hi folks, I wanted to go over the solution by video with you guys. So we have z already solved, which is 1 over e to the power 2 pi I k over 7 minus 1. And so I rewrote that into the rectangular form. And remember, k can be 1 through 6. There's no point in going above that because you're just repeating the same number, since this is the 7th root of unity. And if you're asking why 0 is not included here, because in the previous part we showed that would be undefined on the denominator. Okay, so we go ahead and rewrite this into the rectangular form as you see. And then second step, I collect the real terms, which are cosine 2 pi k over 7 and negative 1. So these are real. I have them on the left side. Imaginary part, which is I sine 2 pi k over 7 on the right side. After that, what I'm going to do is realize the denominator. And there is a way to do that. That is by multiplying both the numerator and denominator by the conjugate. So the conjugate is simply the real part minus, right? Minus the negative of this. So we have a plus I sine theta, right? But the conjugate would be minus I sine theta. So when you multiply it by that, right, which is cosine 2 pi k minus 1, that minus that over cosine 2 pi k over 7 minus 1, you end up with this, the 1 multiplied by that, and this multiplied by this. So that gives you, sorry about that. So that gives you cosine 2 pi k over 7 minus 1 minus I sine 2 pi k over 7. And at the bottom, remember, you can think of this as x minus y times x plus y, right? So this, the real part, you can think of as x, and the imaginary part you can think of as y. So the final answer is actually x squared minus y squared, right? Because if you have x plus y times x minus y, that's what you're going to end up with. So x squared would be, in our case, it would be the real squared, right? So it's cosine 2 pi k minus 1, blah, blah, the real squared. And then y squared would be the imaginary squared, which is I sine 2 pi k over 7, the whole squared. All right? Notice that we're trying to normalize the denominator. And then, so at the top, you end up with cosine 2 pi k, as you can see. And then at the bottom, you have the squaring, which I did for the imaginary. I squared is negative 1. What does that do? That changes the sign into positive here, right? So you should be able to see that here. So it becomes a positive. Now divide by denominator on both sides, right? Both the real and imaginary parts on the numerator. What I'm doing next is, since I have this as real, this is all real, I can divide it, right? Divide the real part by the denominator, and then also divide the imaginary part by the denominator, which is what I'm going to do next. So that becomes the real divided by the denominator, which is cosine 2 pi k minus 1 divided by the denominator, minus the imaginary divided by the denominator again, which is I sine 2 pi k divided by the denominator. All right? That's a lot of stuff, so if you have to slow down and watch this again, that's fine, but I figured I would send this out to you guys. So now what we set out to show is the real part is always similar for all of the solutions. And we have how many solutions? We have 6 solutions. That is the primitive solutions. If you want to just keep repeating the numbers, you can go, they have infinite solutions, right? But so look at the real part, which is our area of concern. Cosine of 2 pi k over 7 minus 1 over cosine squared. Now what I did here is, like, I foiled this, right? Cosine 2 pi k over 7 minus 1, foil it out, meaning, you know, you multiply itself by itself and you end up with, you know, this number itself squared minus 2ab, which in this case would be 2 times cosine 2 pi k times 1, doesn't change anything, plus 1 squared, right? 1 squared is 1 here. Plus, we still have this, right? Sine squared 2 pi k over 7. Now, this is the real part for all of our solutions. How? Because it has a k form, which means this should hold for both 1, 2, 3, 4, 5, 6, 7. So our all the way to 6. So we are working on the real part here, not the imaginary. We're not interested in that anymore. So after that, right, notice that cosine squared plus sine squared for any angle, for any theta, for any k is always 1. So we can simplify that, right? We can get rid of this and this to get 1. And we end up with numerator divided by negative cosine 2 pi k plus 1 plus the 1 from the cosine squared plus sine squared. Yeah, are you guys following? Yeah, so cosine 2 pi k over 7 minus 1 over negative 2 cosine 2 pi k over 7 plus 2, because 1 plus 1 is 2. All right, now this is really nice. It's a really nice formula. We can simplify it further if we took out a negative 2, which is what I did on the next step. I took out a negative 2 here. All right, so when you take out the negative 2, you go from, you have cosine 2 pi k minus 1 remaining inside. Okay, so when you do that, you end up with this nice form where cosine 2 pi k minus 1 is up here, and then at the bottom as well, this and this are the same number. So when you cancel these out, this by this, you're left with negative 1 over 2, which is amazing, which is great. What does that mean? That means no matter what k is, or for all of our solutions, right, the real part is always going to be negative 1 over 2. I say it right here. It says this proves the real part is always negative 0.5, no matter which solution we look at. So proof, meaning, hey, it doesn't matter which number you pick, the real part is truly independent of the solution we look at, which is k, right? K tells us which solution to look at. If you're choosing k to be 1, you're looking at the first solution. If you're choosing k to be 6, you're looking at the 6th solution. But the real part does not care about that at all, as we've shown, because, you know, we did have k in our real part here, but it could be canceled out. So if you were to calculate all the solutions using this long formula, you're always going to get negative 0.5. And so that's your proof for B. And yeah, these writing solutions can be a little harder than the other exercises, but please make sure you go through the transcripts and ask me questions. And also, before you send out any major problems to be submitted, send it out to me first so that I can look at it and point out any errors or mistakes there, okay? All right, see you guys on Monday.